ahead and call.
Yeah, good.
All right. Good evening, everyone. Welcome to the February meeting of the Back Bay Amateur Astronomers. We're back in the home that we should be instead of our ad hoc home that happens every new year, or at least the last couple that we've had. We're gonna go relatively quick this evening, although I'm glad to see the number of folks we have here because we have a extensive and pretty exciting presentation. Rich Roberts is going to be presenting his findings on a variable star he's been watching for a few years. But that's going to be a fairly extensive one, taking us from the very basics on it all the way up to the details. So he needs some time. So in that vein, I'm going to call on everybody like we normally go through the roster, but I would ask for more brevity than I'm displaying right now. That said, first I'm going to turn the floor over to our Vice President, Mr. Jeff Goldstein, to go over the agenda.
I knew it would get comfortable very long.
Okay. No, we don't need no comfort. Okay, I see we got 4 chats. Let's see what that is. Astronomical League on Facebook. We got a link in there if you want to look at the chat. Eastern Med Region of the Astronomical League. That link is on there. Merrill VA Clubs. What's that? Don't know what that is. East Coast Star Party. Never heard of it. Seriously, East Coast Star Party is a big one. Now that's a big event. Since I'm the event guy, I'm not in charge of it, but by golly, I'm the event guy. I'll let Bruce talk more about that. All right, let me see if I can share my thing with you guys. Just one second.
You've been given the power.
Yes, I have been given the power. Yes. All right. I don't know which one it is. I guess it's this one. Doesn't matter, does it? Okay, here we go. For the month of February, today's the 6th. And Saturday, Sunday is going to officially be canceled. I got Jeff Edmondson here, and he says, "No way, Jose." I mean, I said 10%. He says, "No way, Jose." Okay. All right. So I'll cancel that here in a little bit when we have some more time. The next one is Crestview Intermediate School a week from today on Thursday night. That's a nice event. And let me see what the times are. I don't remember here. It's at 5:30 to 7 p.m. and that's in Chesapeake. So I want to share with you a couple of a short story about the last during the week event we had at, where was it? Bayview Elementary? Bayside Elementary. I thought it was Bayview. Bayview. And at Bayview, the kids were thrilled about it. We had a great time. I'm trying to encourage more outreach. And you're going to hear the word outreach a little bit later today. I think the president's going to give some awards for outreach for 2024. All right. So anyway, that's Crestview, and it's the same thing we had last time. Crestwood. Thank you. Oh, that's why it's CW. Crestwood Science Night. All right. Following week, Washington's birthday is probably a holiday, right? Thalia Elementary School STEM. We got quite a few STEMs coming up here. And I've asked for a projector or a smart board for our computer. And then we can have telescopes outside if we can try to do 2 things at once. That's my big plan for both of these STEM things. Cornland, Skywatch, Northwest River Park. I don't know. A week from today, what's a week from today going to look like next Saturday?
Oh, I don't know anything after Saturday or Sunday.
It doesn't go that far.
Clear and beautiful.
Clear and beautiful. Okay.
So probably good answer. Good answer.
So yeah. Northwest River Park's a very good outreach for all of us. And I think that counts for the outreach award too, but I mean, it's kind of a club event, but we do entertain the public at Skywatch, Northwest River Park. There's at least 10 or 15 telescopes, sometimes more. And it's a fun event. If you haven't joined us, please do. The Saturn-Mercury conjunction is going to be real near Deep Creek Park. There's an address here that's the right next to the driveway you pull in. It's kind of like a cul-de-sac, and they're going to have a nice, well, they will have a nice western sky. If we will have nice weather, we'll be able to see Saturn and Mercury conjuncting. They're about 1.5 degrees, so it's not that great a deal. Maybe you guys can get a picture. I don't, my camera won't go that big. All right, please do sign up for that. I haven't checked to see how many have signed up for it. So that's a good one to go to. Woodstock STEM Night, another STEM night. All these people are doing STEM nights, all these schools and everything are having their STEM nights. So we're going to need lots of volunteers. If you haven't volunteered, please do. Ocean Lakes PTA STEM night pending approval. I, I think because I asked them a question and I couldn't get the time right. They didn't have the time, either the start time or the end time. It was one of the things and they haven't answered. So I'll try to find out what the straight story is on the time. Otherwise, I would approve it, of course. All right, in the month of March. A month of March. Okay. Night watch, standard thing, astronomy 101, which was terrible weather yesterday. And I didn't go, but George probably had no telescopes out there, didn't you, George?
No, we had a large group of almost 50 people.
50
signed
people?
up, Yeah.
Yeah.
We had those.
Yeah. Oh, you guys went. I didn't even go.
We didn't go outside.
Okay.
But we brought them.
It was very wet. But please do come and bring your scope for that. That's a big crowd. He has a class. George has a class every once a month, and they love to come out and look at the stars, especially the ones that he talks about. Okay, the next one is let's see, club meeting, astronomy 101 club meeting, Saturday, Sunday, which hopefully will go in March 8th. Garden stars again, and total lunar eclipse on the 13th. That's going to be late in the day. And let's see what the times are. I think it's like 11 o'clock, 11 to 6 o'clock or something like that. So if you can join us for that, that's great. I'm going to try to get a video time lapse of it through my scope. Okay, and that's on Shea Drive, Chesapeake. That's the planetarium if we can set that up. If we can't, I mean, I don't have a confirmation, but if we can set that up, we'll do that. If we can't, we'll pick another time and I will announce it. But that's going to be a good one too. You know, it's only so many lunar eclipses. That's a total too. So I'm glad to report that. Skywatch the following 22nd after Cornland. Spring East Coast Star Party starts the 27th. And that's going to be very good. If you haven't signed up, please sign up ASAP so we can get a good count how many hot dogs to burn. All right.
24th, that's the beginning of Stanton River Star Party. It goes all week.
Oh, okay. The 24th is. And what's Chaos Spring? I don't know what that is.
On Chapel Hill Astronomical Observation Site.
Wow. It says Staunton River Star Party, but it's under Chaos. That's their. I got you. Okay, that's good to know. So if you got two star parties to go to, you got ours and theirs, and we don't exactly conflict. All right, any questions for me? Okay, and we're selling lots of raffle tickets. I've got a whole batch here myself, and I'm doing ID cards for all the new people. Is anybody new or is not a member? Please introduce yourself. Yes. Okay, very good. So we're going to get. Okay. And you're Ed? And your name's Ed, right? Okay, great. Good to meet you. Yes, sir.
Hey, good evening, everybody. My name's Aaron. I'm also a new guy.
All right.
Well, nice.
And you guys have already joined. The reason I'm not trying to, interrogate you, I just want to make sure I get an ID card for all the new people here. So I want to get an ID card for all the new people. Yes.
Also, my name's Ethan.
Okay. Now, if you paid and everything, and after Rich purges all the records for all the people, the deadbeats that haven't paid, then I get the list of all the new ID cards to make. Okay. So I'll be sure and do that for all of you guys that need one. And I already got a list. I've got two listed. If you don't have an ID card, let me know and I'll make sure, and you are a member for a long time, whatever, I'll make sure you get one. Okay. Questions on that? Thank you very much.
Thank you.
That's my list.
All right, next, I'm gonna turn it over to Gabe Dandrade for a executive summary and highlights of last meeting's minutes with the caveat that we have them posted online. So.
Oh, I didn't stop share, I'm sorry.
Well, it's fine. I need to get to the club website anyway, so. Oh, that's, hold on. Just a second while I just pull it up. It's just gonna be 1 second.
Myself, oh, please.
Yeah, go feel free to introduce yourself while I set this up.
Just a guest, I hope to join. My first name is Silvio, and last name is Condon. I live, villages at West Neck, and I came across the webpage, about a month or so ago, and I'm interested.
Great, perfect. We're a public group, so if you want to join us, we'd love to have you. And also, as a reminder to everybody, new folks, older folks, not older folks, but people who've been with us for a time. Just please understand that many of us feel a little bit, myself mostly, much included, are a little nervous about admitting that we don't necessarily know people's names, faces. There's over 200 of us. I would like to remind everyone as astronomers, we spend a lot of time around each other in the dark. So you can always fall back on the, I am so sorry, I'm still trying to put your voice to your face in the light. Can you remind me of your name? There's your freebie on how to avoid that awkward situation.
I have literally used that like I think a dozen times at this point, so there's absolutely no shame inducing in having to say that. Like, there's no one's gonna like fault you for that.
There you go.
Yeah, but anyways, so I have the minutes from last month pulled up here. I'm gonna start at 7:30 on time. These are the people in attendance. Calendar of events, all the reports went according to plan. Except treasurer's report is a little different because Rich was not in attendance, so our dear President Jeremy gave an abridged version talking about like the memberships and that sort of thing. Bruce gave his Alcor report as usual. There was no scholarship committee that night. I should also mention that we held it at Kempsville Rec Center instead because the TCC, the building was still closed. And last but not least, so the special program last week was commentary observing about the Rosetta probe that was launched by the European Space Agency in the early 2004. It was a really interesting video that we watched about like how like it was the first orbiter for a comet, how it had a lander that was sent to the surface to take samples. The meeting was adjourned at 9 because at that point we would have been literally kicked out of the room by staff. For those of you who were there, you would probably remember that very well. But yeah, like the meeting went according to plan, and it was a great time. And that's really all I have. Like again, like don't want to take too much time from Rich's precious seminar.
Very good.
Excellent, good job.
I have a motion to accept the we have a move properly seconded to accept the minutes as read and summarized. Can I get a vote? All in favor? Aye.
Aye.
All opposed?
Aye.
I'm gonna call that a time gap rather than a. All right, the motion passes. So minutes approved. All right, next, Rich, it is over to you for the treasury report. And I will stop sharing.
I booted it.
I will stop oversharing.
So we have quite a bit of money, over $15,000 currently in all of our accounts. Just over 10,000 in our general administrative fund, and then we hold two separate scholarship funds, 3,700 in primary. I just deposited last month a $2,000 check. For those who don't know, we get $500 for every Boardwalk Astronomy event that we do. So we did 4 last year. So we got $2,000 from this company that has a contract with the city of Virginia Beach. So that went in, and that went to our scholarship. And then we got a lot of money in because everyone was renewing. Well, not everybody, but a lot of people renewed their dues. So we're sitting in a good place. This was an increase of $2,000 from what we had in the previous month. And that's despite having some pretty substantial expenditures, like our paying for our insurance, paying for our PO box. There's a lot of stuff that happens in January, as well as I got our taxes filed, which is actually pretty easy. Since being a nonprofit under $50,000, I just have to fill out some forms for the IRS. On the membership front, we have 213 members on the roster this month. That was an increase of one over the previous month. That's about to be changing quite a bit because I have to do the February purge. You know, all our dues are due at the end of the year. You get a month grace period. There are some checks that I know that are outstanding from people who spent a check, but Ben just told me he checked the PO box and sent it to me. So after that, I'll be able to start cleaning people out. We currently have 55 people who have not paid. But after I get those final checks, like 5 or 6, we'll probably be at 160 going into March. 160 members. To see how that compared to last year, I was just curious. At this time last year, we had 209 members, and 65 of them ended up not renewing. So we're in a better place. We have starting from a little higher threshold, and we had more people renew than we did last year. So membership remains extremely strong. I remember when I joined, it was crazy that when we would get over 100, and then the purge would come and we drop into like the 70s and 80s. So we have a good amount of money, plenty to fund all of our activities, and strong amount of members. That's all I got.
Thank you, Rich.
Does anyone have any questions? I guess I should say that. I hope not.
Who would question you?
I have no questions.
I move we accept.
Yeah, no questions, no auditing, no Doge, nothing for treasurer. I'm good.
It has been moved and multiply seconded to accept the treasurer's report as briefed. All in favor?
Aye.
All opposed? All right, motion passes. Report approved. Alcor, Bruce Powers, are you with us and not in pajamas?
I am not in pajamas.
Promise?
Bring tickets. We can only see the.
No, yeah.
Yeah, actually, don't answer that.
Yeah,
Waste
I
people-
regret the question.
That is top secret.
All right.
All right. So I promised my presidential colleague that I'll be brief, be bold, and then be gone. So for those of you that are new, when you join the Back Bay Amateur Astronomers, you get the Reflector magazine, which probably doesn't show very well here, but anyhow, the main idea is that we are part of a national organization that is roughly about 40 to 50,000 people and over 200 clubs. You see that a little better? Yeah, that's the Reflector magazine. Okay, so we already went over the last recipients of awards. The Solar Eclipse Observing Challenge was reeled in by Jeff Goldstein and Eddie Paris, and we covered that last month. Okay, so what I'd like to briefly introduce you all to, if I can share, if I'm allowed to.
We'll allow it.
Okay, can you hear me and see my screen? Okay.
Actually,
All right, so Roger Lima Charlie, I have you 5x5. So Astronomical League also has a Facebook page, and I would show that to you here on tomorrow night. And they do this about once a month. There will be a Astronomical League live event tomorrow night, 7 p.m. The title is The 10 Illusions of the Night Sky, done by Tom Reiner. Anyhow, if you want to participate in that, you just go here to this Facebook page, which I've also put in the chat, and then you can participate right here where it says AL Live. Okay. All right. So in addition, there is the Mid-East region of the Astronomical League, otherwise known as Merrill, which not a lot of people know about. If you've ever seen these charts navigating the X night sky, that's put out by Mr. Don Knobb, who's part of Merrill. And I handed out a lot of these at our last Chrysler Museum event, and a lot of people like them. So you can see Venus blazing over there on the west at sunset. Anywho, they update these every month. These are fantastic handouts for outreach events. Okay. And big surprise, the Mideast region of the Astronomical League is headlined by us. Okay. So those are all the different astronomical societies in Virginia. And lastly, I want to do a shameless plug for the East Coast Star Party, as has already been mentioned. It is March 27th through 30th. There are many, many questions about how this event are all expertly answered on this site. So please read it and register. It's a great time. This is some of the video taken by one of our members of a time lapse of the Chip Oaks night sky at Mr. Mel, and check it out. It's a great site, and Sean Lozier designed it. Okay, so what the heck am I doing for the East Coast Star Party? I am buying the raffle prizes. I am updating the paper schedule as always. I'm ordering the porta potties, not to be overlooked, because they are a critical piece of equipment that we all need for that event. And I will also cover the Friday night astronomy presentation if it rains in the conference shelter at Chip Oaks. And if it's clear, then I won't do it. So my last item is this month in February, I am going to order the raffle prizes from probably Oregon Scientific, because sadly the Orion Telescopes is no more. They have closed their business. So I would like to ask what my budget is. I've previously gone wild with about $650, $700, and this requires an approval. So name your price.
I would suggest we stay consistent.
Okay, so 650.
I moved to up it to 700 since we got extra bucks.
So there's an official motion on the floor to up Bruce's budget for prizes to $700. And a second. Any discussion? Rich?
I'm
Okay. Fair enough. All in favor?
Aye.
All opposed? All right, motion carries.
I just want something good.
Okay, $700 it is, and I conclude my report. Thank you.
Thanks, Bruce. I will take that, your budget item, off our new business line. Okay, that also covers the East Coast Star Party Committee report. I will now go to Mr. Ben Loyola of the Scholarship Committee, and if you also want to say anything about the RRT.
We have a lot of new folks here today, so welcome. The Back Bay Amateur Astronomers, and I'll reemphasize this, is a 501c3, so we're a nonprofit instructional corporation, basically. So your contributions to our club are tax deductible. So if your employer does matching funds to nonprofit organizations, please do that. Money that goes to a scholarship, tax deductible. So welcome to donate. For many years now, we've had scholarships. We have currently 3 running right now. We have the Back Bay Amateur Astronomer Scholarship, which is now up to $1,500. We have the Georgie June Memorial Scholarship. Georgie June was a wonderful member of our club. Unfortunately, we lost her way too young in life. So we established a scholarship in her name, and that's at $1,000. And then we also had another member who also passed away, super young and quite talented. And the City of Virginia Beach is supporting that, and we're administrating that. The Nick Anderson Memorial Scholarship, and that's $2,000. So for a club this size, it's an amazing amount of money that we give to young, qualified individuals that are really very, very incredibly talented. So right now, the scholarship will be set where it was last year as well, and we'll get that information out throughout the Hampton Roads area. The Nick Anderson one is specifically set aside only to Virginia Beach schools, and that's an administrative requirement by the City of Virginia Beach. And just, there's right now 3 committee members. George Reynolds is on the committee, and Matt, hello, Matt, Monaghan is on the committee, and we meet, the applications are due May 1st, and then about a few weeks later, we give a couple weeks to school in the PO box, and then we get the applications and rank them based on their academic achievement, a 500-word essay, a teacher's input, and their GPA. So we put all that together in kind of a spreadsheet and a weight factor, and then we select the top 3 recipients of that. And we usually invite them to come in and read their essay, which is really fascinating because a lot of them done some really amazing, real research as a young student. So they share that with us, and it's a real pleasure. And they go off, hopefully go to college and continue in scientific endeavors. So
That's what happened. That's what I did. I mean, when I was a high school student, I applied and I won the Georgie Jean Scholarship with my essay, and now I'm an engineering student.
There you go.
Just an example of how it works in practice.
Awesome. So it's an amazing thing that our club offers to the community, and it's really honored and proud to be able to be part of it. So and the support of our scholarship committee members, and we've done it for, I don't know, probably 15 years now. And it's grown and grown and grown and grown. And I think probably next year it's going to grow some more because we got a good amount of money coming into the club. So if you don't have any questions, let me know, and tell anybody you know in school, because typically we don't have that many applicants. I mean, because they got to show their interest in astronomy, or in sciences, and some of the schools don't offer any type of astronomy type stuff. So we take the inputs from the science teacher. So, there's a really good chance of winning that scholarship, one of the 3. So tell any student that you know at senior type about to head off to college, and point them out on the website. It'll be on the City of Virginia Beach website, Hampton Roads, Chesapeake, Suffolk, Portsmouth, all the way around. But we really only get a handful of applicants, as much as we try to market it. Any case, all right, that's all I have.
Do we have a flyer that we could?
Yeah, it's a flyer. It's a flyer. Yeah, we post up on the website here. So we set them out. So we'll send that out here next couple of days.
Okay, great.
Yeah.
Thank you.
Oh, and then you wanted to mention the RRT.
If you have
Okay,
any,
so let's continue on. Okay, so the RRT Rapid Response Robotic Telescope. It's a combination of University of Virginia and Norfolk State University. It's over $1 million telescope up in Fan Mountain, which is in Virginia, about 3,600 feet, pretty high up there. Been out there a few times, and it's fully accessible to us to use as a club because we're kind of like the supporters of that telescope. So they give you credit points, and you just let me know, let the organization know, and they'll give you credit points, and then like typically give you 10,000 credit points, and then you want to observe, and they got a little planetariums application that you log in once you have your login, and you say, I want to image whatever, whatever you want to image, and the camera's already set and how long you want to expose for, and they download the files. They give the files in 2 formats, JPEG, so you can, the pretty picture type stuff, so you can just take a look at it, but also give you the FITS, which is the raw image that's used for astronomical processing. So you could do asteroid work, you can do planetary work, you can just take pictures and stack them and get some really nice black and white images. So RRT, you can look it up on the internet, Rapid Response Robotic Telescope, and just let us know if you're interested in doing it. There's no charge. And to have access of $1 million plus telescope that we help actually operate and install, it's really a really incredible opportunity there. And it was a original NASA research grant. They wanted to track the supernovas. So they're RRT, rapid response, see what's over here and see what's over there. It was a global network of telescopes, and that program came and went, and now it's just being used by students in astronomy curriculum in their college program. So for the most part, it's not used. So it's an incredible resource for everyone to use if you want it. RRT.
as a plug and kind of bridging between Bruce and Ben, if you go onto our website, look at some of the observing programs the Astronomical League has. One of the columns in our Astronomical League program finder is our remote telescopes authorized. So there's a lot of opportunity to synergize Astronomical League observing programs with our, what I would consider to be our home remote telescope. Okay, thank you. I'm also going to say next will be for the Refreshments Committee, which I would like to start by offering my thanks to George Reynolds for resurrecting with coffee and snacks. If you have anything to
Coffee, cookies, feel free to come up anytime during the meeting, get yourself a cup of coffee, and it's free. If you want to make a donation, that's fine, because it's a self-replenishing coffee fund, so any money goes in, just goes to buy the coffee next time. So feel free to come up and get some coffee and cookies.
Thank you, George.
Thank you, George. All right. So that covers our officer reports and our committee reports. We're going to shift over to old business. Our first order of old business is last year's outreach. Our club vice president, Mr. Jeff Goldstein, has very kindly ordered the outreach pins that we have for club members that did outreach events last year. I went and pulled a list of all those folks, and quite frankly, from what I've seen, we have a lot of folks who have been doing outreach and haven't been taking credit for it. So I would ask that if I don't call your name and you know that you have been doing outreach, or you know other people who have and aren't on the list I'm about to name, please go on to the Night Sky Network page and log your hours and your mileage, because that's something, as Ben mentioned, we're a 501c3 organization. Correct me if I'm wrong, outreach events are tax deductible for your mileage. So
Federal rate.
on the at the federal rate, which is I think 45.
Oh, it's higher now. I think 60.
Oh, okay. So now, granted, the likelihood of you itemizing your taxes is a lot lower now than it was several years ago. But if you're in that category, it's an option, and also it allows us to recognize you for your hard work and allows you to take advantage of some of the other outreach observing award programs.
One more thing, Jeremy.
Yes.
That's also how we get all the cool stuff from there.
And yes, and it's how we get cool stuff for NASA. We
Show
as
that we're doing all these events, so they send us more kits and stuff like that, the banners and everything.
okay, some of which we put on great display at the Chrysler Museum event last week, which was great. And while I don't have the email called up, they did reach back to thank us and made sure that they wanted us to know how much positive energy and vibes were directed our way as a result of that event. So in no particular order, actually there is a particular order. It's the order that the everyone was listed chronologically by first occurrence. You have I have the pins. Would you care to donate or distribute?
I will help.
Excellent. All right. First off, Roland Downing, who I cannot give a pin to through the screen. Okay. Jeff Goldstein. James Sorensen. Don't think James.
Nice pin. Wow.
Oh, what is the pin this year?
It's really pretty. It's heavy too. You can put somebody with that thing.
Thank you, George, as an example.
Better than the observing pin.
So this year's pin, Night Sky Network. What am I doing? I can't.
Maybe I can.
All right. David Fontaine, not with us tonight.
That's what they look like.
Sean Lozier, getting coffee. Me. Jonathan Sheets, who is, I also can't pass that one through the screen. We'll get it to you next time we see you. Rich Roberts, I'm detecting a trend here. Mel Spool is not with us this evening, and we won't have Saturday, Sunday this week, so we'll see what happens. Michael Rousseau, Patrick Bartuli, George Reynolds. Time. Jeff Thornton, also in Zoom land. Michael Webster, Eddie Paris, Kent Blackwell, Soham Patnik. I'm sure I'm butchering that pronunciation. I'm so sorry. Joseph Brown, Jennifer Davis, and Lawrence Puckett. If you know that you did some outreach events this past year, included going to Night Watch, Skywatch, helping out at our event at Japokes, please take credit for the event that you did. Help us with getting more Night Sky Network assistance so that we have more things that we can distribute. Get yourself a small tax deduction, and let us recognize you with a pin. If you Oh, yeah, we can have, well, I'll give you this list. Okay. In a second. I would ask that if you do go in and backfill, to make sure that you get that recognition, also send Jeff and I a quick email so that we can make sure that we get a pin ordered for you. Just so we can get that there. All right. Okay. So thank you for that. Next item of old business, as we discussed last meeting, we need new business cards. Thanks to the efforts of Sean, we have new business cards. So George has a packet. I have a packet. Sean has a packet. You need a packet, and we'll hand some out to two folks so that we can distribute them to new members. Okay. Next item for new business, only item I'm tracking right now is we are in the process, new year. We have a new couple of officers and a few officers whose cards, or past officers, who do a lot of work for the club whose cards are expiring. So we need to get new bank materials processed. In order to do that, we need a note approval from the club to change who the custodians of our account are, as well as Gabe needs to document the minutes and we'll need to bring it to there. So I apologize for the actual business portion of the business meeting. But if there is a motion, if there would be a motion from the floor, one proposed roster of names would be myself, Mr. Jeff Goldstein, George Reynolds, who has agreed to continue to assist us in our menial chores, Rich Roberts, Bruce Powers, so that he can order things for the East Coast Star Party, and Sean has agreed to also continue to do menial chores. Gabe, did you want to put yourself on that list or no? Looks like no.
Yeah.
Okay.
I think I wouldn't just have time, honestly.
Is there any, I'm opening the floor to discussion if anyone would like to propose an addition or a subtraction from that list. If you propose a subtraction of me, I won't really complain, but it'll make it a lot harder for me to deposit people's checks.
I so moved that we put those people you just said on the account.
I'll second it.
Great. All right, we have a motion and a second.
Let's vote.
All right, no discussion. All in favor?
Aye.
Any opposed? All right, motion passes. Gabe,
Rich,
write
do
that
you
down.
see the statements?
Yes.
Okay,
Excellent.
I will not order large amounts of furniture from IKEA.
All right. Due
Well,
to
whenever I see charges, there's one thing that George and Sean are always good about is emailing me receipts. Because otherwise there are times where people who I finally got them trained, because I'll go in to do the books at the end of the month and see stuff, then I have to start texting people like, who did this, who did that, and there were less there's going to be more card holders now. So I do want people to give me heads up when you're buying things, or at least just text me or email a receipt. So it makes it easier on me at the end of the month.
Yes, sir. We want you to continue to be willing to do this. So yes, we will absolutely do that. All right. This is also a point where I would normally turn it over to observing reports, but in respect to the extent of discussion, I'd like to table that until after Rich's presentation, assuming there is still time and interest. Is that acceptable to the group? All right. In that case, subject to any other new business, I'm going. Yes, Sean.
We should decide how much money we want to spend on the gifts for the summer picnic, because you and I have to go submit the application.
Yes.
And you're probably gonna be buying it, or me.
Yeah.
So, but we need to order that stuff in advance, to make sure it's here in time.
Okay.
So how much do you all want to spend?
How much
Well,
was that last
we
time?
get gifts, not, this isn't the food, this is the raffle stuff we hand out, like, for people out of there.
Okay.
Typically, we do, in the past, it was like $100, $150, maybe, something like that. So,
I believe that we approved $200. Second.
All right. Move in a second to approve $200 for door prizes, gifts, etc. for the summer barbecue. Discussion. All right. All in favor?
Aye.
Any opposed? Motion passes. Spending a lot of money tonight, which is good. Okay. Any other new business? Thank you, Sean, for coming up with that one, because I didn't think about it. All right. In that case, Rich, I turn the floor over to you, and I'm going to go grab my pen to take notes.
All right. Let's do this. All right. So we are going to talk about a star I've been monitoring and taking photometric observations on for several years. It's V725 Sagittarii. And I put this picture up of the island of misfits toys, because I think about this star every Christmas when I'm watching Rudolph with my son, because if there was an island of misfit stars, this one would be on it. It's right in there with the Charlie in the Box and the train with square wheels. It's weird. And there have been several attempts to try to classify it over the decades. And there's some theories out there about what might be going on. And based on the study that I've been doing for the past couple years, I may be able to lend some shed some light on the validity of the hypothesized theories. So really, I got involved with this star. It came about. It was fall of 2019. John Percy, who's the dean of physics at the University of Toronto, reached out to me, and he sent me a pre-release of a paper that he was writing. It was actually, the paper was a follow-up to the follow-up of a paper he wrote in 2006 on this star. And he was using John's kind of niche is period analysis, and he studies pulsation modes of variable stars. He literally wrote the book on variable stars because I have it on my shelf. But he noted, or the reason he reached out to me is he was using Assassin, the all-sky automated survey for supernova. They also they image the entire star every night, or the entire sky. And it's just free to, anybody, you can go download anything from these images. It's pretty good. And he was downloading this, and he was trying to find new truths about this star from that data. And it just wasn't sufficient enough. Like, it was good enough for what he was doing, but it wouldn't unlock the mysteries of the star, and it would not be able to prove what is actually going on. And so he reached out to me and said, "Hey, Rich," because at the time I was the section leader for AVSO's long period variables, and he said, we needed more systematic approach of this star, and we need to look at the colors, and we need to look at some other things to be able to figure out what's going on." And so he wanted my help, and I said, "Sure." And then I did what I would normally do whenever approached with opportunities like this. I tried to pawn it off on somebody else. And so I'm looking at this going, yeah, there is definitely an observing project here. But obviously I'm not the best suited person to do this. I'm not an experienced photometrist, and this star has a declination of -37. So for just reference of how far south that is, that's the same declination of like the cat eyes in Sagittarius's tail. So that's how far south this star is. So not a great observing project for somebody who lives in Virginia. So I reached out to guys I know at another organization called Variable Star South. They are a group, most of them are AAVSO members, but the AAVSO promotes less project-based kind of observing. They say just go out and observe a lot of stuff, put them in our databases, and then the data will reside there for somebody to do something with it someday. Variable Star South, they like to concentrate more on project-based items where someone can go and take an observing project, and then at the end kind of publish some results either in a scientific journal or in one of their circulars, which they put out every quarter. And so I did that, and I was like, initially I got some guys going, yeah, this sounds pretty cool, let's do it. And then I never really got anyone to commit to actually dedicating their telescope to data collection. We also, when I was talking to them and trying to come up with a project and how we would organize it, we had some differences of opinion on how it should be ran and organized. Me being the AVSO guy wanted it to be a larger project of many observers and wanted to put out a set of, this is what you're going to do for this project. And I wanted all the data to go into the AVSO database. And they wanted to keep the data kind of behind closed doors and until something was published. And so in the end, we didn't come to terms on what we were going to do. And so they went on their way, and I'm still sitting here, and I was unable to successfully pawn it off as I wanted to. And so I get the idea of, you know what? I'm going to do this. And I did this. Whenever I see this meme, I think about this day when I decided to do this. Because it was the truth, man. I do this not because it is easy, but because I thought it would be easy. And that was, if you told me then how many hours I would have sunk into this star in this project, I would have said, I'm out, man. Peace. But it's actually been kind of worthwhile, and I've learned a lot of things along the way. So that's kind of how I got involved. I'm going to pick the story back up with what I'm doing now and what we've learned. But before we get into it, just so if you read any scientific paper, it always starts with a literature review, and that's just to bring everybody up to speed about what we're talking about and why this paper is being written. What are you trying to figure out, and why is it interesting? Or I know when I had a class on research methods when I was doing my MBA, the professor told me the real reason of the literature review is just to prove that you know what you're talking about. So to really start understanding this star and its story and why it's so unique, it begins with the discoverer of Henrietta Swope, who discovered it in 1935, and she published in 37. Henrietta Swope worked at the Maria Mitchell Observatory in Nantucket, pretty famous observatory that hired all women. And she was a Cepheid hunter. Cepheids were very in fuego back in this time period because, for those who don't know, Cepheids have a distinct period luminosity relationship. So if you get the period, you get the luminosity, which means you can figure out how far away it is. So this is what's used to, it's one of the rungs in the cosmic distance ladder. This is how we determine distances to nearby galaxies. It was just about a decade prior to this when that's how Hubble figured out the Andromeda galaxy. He solved the spiral nebula. He said, Andromeda is not part of the Milky Way galaxy. It's its own thing way over there. So this was big time work. She comes across this star, thinks it's a Cepheid. So then she pulls all the glass plates from Harvard College Observatory, the famed glass plates. She starts to do analysis to try to get this period. And then over the course of it, she started reconstructing the light curve and said, something really weird is going on here. She kind of breaks it down in her paper as I have listed here, from 1890 to 1900. It was pretty, it had a constant period. And then for about 26 years, it was very irregular and it varied up to a magnitude. In 26, she established again the 12-day period. But then she noticed from 28 to 35 that the period was increasing by 1 day per year. So this is not Cepheid behavior. And by 1935, the variations were up to 2 magnitudes in amplitude with a 21-day period. And so she goes, okay, it's not a Cepheid, and she just drops it, which is tragic because this star is so much more interesting than a Cepheid. Of course, again, back then, Cepheids were the thing, and now we just find them boring because we've really unlocked all their mysteries. But unfortunately, this star was forgotten about and not observed for decades. And so we just don't know what it was doing until along came Serge Demers, and he published his paper in 1973. He was a young astronomer. He was a resident astronomer at some scope in Chile. And he just came across a star and said, you know what? I'm going to try to classify it. He read Swope's paper. He couldn't figure out what it was. I'm going to try to classify it. And so he falls back on what was the standard of his time. Still, it's kind of old school today, but he was using the Johnson photometric system, which we've now expanded quite a bit and are shifting to other ones. But to understand, a photometric system is a set of filters. They could be broadband or narrowband. And these filters are established, or these passbands are established in a way so that when you actually plug them into some sort of mathematical formula, you can determine physical properties of the star. The Johnson system's been around since the 50s. It's one of the most widely used ones. And it has three filters, U, B, and V. U being in the ultraviolet, B in the blue regions of the spectrum. And Johnson, when he designed his system, in the blue channel aligns with the old photometric plates used by Harvard. So that's why he did it, so there would be consistency, because so if you look at Schwab's data, it's all really in Johnson B, and then V. And so when astronomers use the term magnitude, they're talking about flux through a filter. Then when they talk about colors, which we're going to talk a lot about here, that is the difference between those two fluxes. And the reason they do this, magnitudes are apparent magnitudes. They're dependent on distance, because if you take a light and the further you move away, the dimmer it gets, even though it's the same brightness. But you take a flashlight pointed at your face and move it away, it's going to get dimmer. The flashlight didn't get dimmer, it's just further away. But if you think about it, so with a photometric, it's like B minus V is a color. If you move the star back, those are independent of distance. They're intrinsic to the star itself, because the easiest B minus V to remember is Vega. It's 0. B minus V equals 0. So if I put my CCD, I put a Johnson B filter in front of it, I would get a magnitude. Then I would measure it again with a Johnson V filter, get a magnitude. They would be the same, because that star is emitting the same amount of light in the blue channel as it is in the V channel. If I moved Vega twice as far as it is now, the B magnitude would drop by a quarter. So our 1 over R squared law. The V channel would also drop by the same amount. B minus V is still 0. It doesn't matter how far Vega is. B minus V is always going to be 0. So that's the kind of the Johnson system. It's 3 filters, 2 colors. U minus V, which is used to determine the Balmer jump. This is only relevant in the hottest stars to see where the strength of hydrogen ionization is not really that relevant or used that much anymore. But B minus V is. When people talk about the color of the star, it's kind of like people, if you're football fans and people go, the Ohio State University, when people say the color, they're talking about B minus V. There's other colors out there, but that's the color, because it directly relates to temperature. So if I get B minus V for almost all stars, not all, but most, I can figure out almost everything I want to know about the star: size, mass, temperature, all kinds of stuff. So that's what he was really trying to do. He was going to measure in these 3 filters, get these colors, determine what the star is, right? So he comes up and here's his data. Here's the light curve for the 2 years. One thing you can note, and you'll see this is a theme, it's common for professional type telescopes, is the cadence is not super high. So he kind of has his amplitude listed, but I don't know if he caught all the minimas and all of the maxima. But you'll see he did have a B minus V, 1.36. Great, that could tell you things. If only it were that easy. As I told you before, B minus V is an intrinsic property of a star. So if I get it, I know what's going on. However, he measured this B minus V. That's not the star's B minus V. Why? It's because, think of the constellation that we're in. We're talking about Sagittarius. We are looking towards the center of the galaxy, and there's a lot of dust between us and that star. And so what the effect of dust is, dust attenuates bluer, or stuff that's at a shorter wavelength is attenuated easier by dust. So that's your blue light. So the dust knocks out the blue light, but lets the red light go through. So that makes the star appear redder than it really is. And just for reference, with B minus V on the scale, the higher number is redder, small numbers are bluer. So, Vega is 0, that's a pretty white star. If you went to some really blue stars like Rigel, they're going to be in the negatives. I think our star is like 0.8. Our LEP is like 5. The carbon stars are like 5 or 6. So anyway, he knows that he's got to figure out, he has to do some kind of correction for this if he really wants to figure out what's going on with the star. So he attempts to do that. Now, one of the problems is he didn't know what the reddening was. He did have the work of Vandenberg, who studied different globular clusters that were along that line of sight. And he noted in his paper that the reddening in that area is highly irregular, but it ranged from 0.17 to 0.68. And so how the effect of that is how that would work. E B minus V is what's called color excess or reddening. You would take your measured, and then you would just subtract out whatever the reddening is. So if you measured 1.3 and you knew reddening was 0.2, then the actual B minus V of the star would be 1.1. And then you could figure things out. You would know things. But this is a pretty substantial range. He had other problems. He didn't know the distance, which meant that he couldn't figure out like where it was above the galactic plane to do a bunch of trigonometry about where the star could actually be. So all in all, he had a a multivariable problem here. So how do you do that? So he had to just do trial solutions. He was just plugging and chugging different possibilities, trying to chart them out to see if he could find a relationship and to see if any of those would back out into a known stellar category so that he could say, yeah, that's what the star probably is. I gotta tip my hands off to Serge here because that's an insane amount of work. I mean, this would be easy today. You just write a Python script and be done with it in 5 minutes. He's doing pen and paper. And so he comes up with this. Like he just like guesses at solutions, tries to plot out different reddenings at different radio velocities, doing the trig to see if it could fit. And now but he also had to narrow it down some. And so he made 2 assumptions. And they weren't bad assumptions, but he had to make some assumptions. So the first assumption he made was that he figured due to dust and reddening in that area that the star would have to be a supergiant because that any giant star would be too dim. He also assumed that this would be a population 2 star. Population 2 stars are metal poor stars. They're only hydrogen and helium. They're first generation. Population 1 stars like our star are second generation. I know it's kind of backwards. A lot of stuff is in astronomy because they like name things before we really understand them. But because this is in the galactic bulge, that is a common place to find population 2 stars. So it was a good guess. So in the end, he comes up with 2 workable solutions. He likes the first one mainly because it's kind of in the middle of your reddening range, and he didn't want something too far out, like or too close or too high on the reddening scale, and it kind of matched up well with an RV Tau star. RV Tau stars are amazingly interesting. They're one of my favorite stellar types. But in the end of the day, he was like, yeah, based on what I'm doing, it's probably an RV Tau, but he's explicit that he had to make too many assumptions and he can't conclusively prove that that's what this star was. And so he did a lot of good work. That's where he left it. It was his best guess. And then the star gets forgotten about again for decades, unfortunately. So the next time this star appears in literature is by the aforementioned John Percy. One of his, I think she was either a grad student or a postdoc at the time, now works with him at the university, Amy Wulau, brought this star to his attention saying, hey, I found this really weird star. Let's do a study on it. And so what Percy did is he went back and looked in the AVSO databases to find, and he found that there were people observing this star visually. Really from the mid 80s to the early 90s, there were 2 guys looking at it, Overbeek and Peter Williams. Overbeek was in South Africa, and Peter Williams, he's a New Zealander. He's a good guy. We're Facebook friends. He's a prolific observer, but he took their data and then he banded together a couple other observers. Overbeek by that time had passed away, but Peter Williams is still with us. So he jumped on board, started observing again, along with some others, doing some photometry. And what was interesting about it, this was the most interesting result. What I have on here is he just graphed the period over time. And so early on, this is the slope data where we didn't really have much and we saw this increase. It was constant for a while, but data was sparse. Then it started increasing by day. I didn't mention in Demers' paper, he, in his data, found a 45-day period. So that started here. And then these others to the right in the 90, 2000, he looked at each observer's data set kind of separately and did a bunch of analysis on it and found out what the period was. And he just charted them all out over time. And you can see from this is this period is continuing to increase at a fairly steady rate. This is something you do not see with pulsating stars, not to this degree. Yeah, you see it with like eclipsing binaries because the system's changing, like the two stars are moving apart or something like that. But you don't see it in pulsators. So this is really weird. And this is the first time that it's suggested or a theory is thrown out about what could be going on here, where John looks at this and says, maybe the star is undergoing a blue loop. Blue loops are a theoretical idea and have not been observed that we know of or proven at this point. But before we go further in literature, I'm going to go over what is a blue loop. So this is a Hertzsprung-Russell diagram. This is the base thing that you need to understand if you want to understand what goes on in stars, right? And so on the vertical axis is absolute magnitude or luminosity. Both can be interchanged. And then on the bottom scale is temperature or spectral class, or color. They can be interchanged. However, it's inverted. So on the left side is the hotter temperatures or the bluer stars. And then as you move to the right, you're actually going down in temperature. And you're going down on the spectral classification. Also down in mass. The higher mass stars are to the left, lower mass stars to the right. So if you look at what goes on inside of a star like our sun, the stars kind of migrate through this chart over time based on how they evolve, based on what's going on inside the center of the core of the star. So on this main sequence, that's where 90% of the stars are. They spend 90% of their life there. A star like our sun, in its core, is fusing hydrogen into helium. All right, we're going to say it will do that for 10, 11 billion years. Eventually, all that hydrogen starts just building up in the center, right? But it's inert. So at some point, this is going to happen to our star, is you're going to get this inert helium core, and then you're going to get a hydrogen burning shell that surrounds that core. When that occurs, we are going to become a red giant star. And our star will start to expand out and it will become cooler. So it'll move to the right of this Hertzsprung-Russell diagram and up because it's going to become more luminous. So this is going to occur over 1 billion years or so. Eventually, that helium is going to get the conditions it needs to start to fuse. When that happens, now you have a helium fusing core, hydrogen fusing shell around that, and it's going to become what's known as a horizontal branch star. It's going to heat up and start moving into the yellower regions of the Hertzsprung-Russell diagram. And the waste product of that helium fusion is carbon and oxygen. And carbon and oxygen are never going to fuse. Not in a star that, when on the main sequence, was 8 solar masses or lower. So then, eventually, we're going to get to this point where that carbon and oxygen really build up in the core. So you have an inert carbon-oxygen core. That helium shell around it is going to be inert, and then you're going to get hydrogen fusion around that. That's when you get to the asymptotic giant branch star, the AGB. This is the land of your Mira stars, your SRAs, all your big pulsating stars, the ones that I love. This is what I study, are AGB stars. So it's a very interesting part of solar life, and it doesn't last all that long. But when it's on the AGB, one thing that we do know that occurs is at times that helium shell that's around the core will get the conditions to briefly fuse. It like just will turn on and turn off. And we call those thermal pulses. Those happen to an AGB star about 10 to 20 times while it's on the AGB before it finally fusion just goes away and then everything drifts off to a nice planetary nebula. We know that they occur because there's tracer elements, technetium and lithium. If we see those in the spectrum, we know that a thermal pulse had occurred in the last several thousand years because those elements, especially technetium, have very short half-life. So they decay quickly in the stars. They don't last long. So if we see them, we know that a thermal pulse happened. What has been theorized about, people have thought about is like, what happens to the star when the thermal pulse occurs? Well, people have modeled this and said, well, it would probably happen. The amplitude would decrease and the period would decrease, and the star would move to the left and become into the more yellow parts of the Hertzsprung diagram, Hertzsprung-Russell diagram as it heats up. Then eventually it's got to travel back, and then the opposite would occur. Period would increase, amplitude would increase as it moves back into the redder regions as it cools off. That kind of sounds like what's happening to V725. Maybe this star, when Henrietta Swopes saw it as a Cepheid, which is in the yellow period, that's those are F, usually spectral class stars, some into the G's. And now we're watching it come back. And maybe that's what's going on. This should happen over a course of a couple hundred years. I mean, it doesn't happen in the lifetime of a star is minuscule. It's like a rounding error, right? So maybe that's what's going on. So the other question is, have we seen this kind of behavior anywhere else? Have we only seen it with V725? Because it would lend credence to the idea that this star is potentially undergoing a blue loop if we see somebody else doing it. We have another candidate, and it wasn't mentioned until very recently. So this is T Ursa Minoris. On the left, this was actually a project I was doing. ABSO has like classes you can take to do analysis. I was learning how to do their analysis software and do Fourier transforms and all that kind of stuff. And this star was one of the case studies that you had to solve, basically, because T Ursa Minoris, it was discovered at the turn of the 20th century and been followed very religiously by ABSO observers for 100 years, right? So it was a very well-behaved Mira star, just doing normal Mira things, pulsating back and forth very regularly with a high amplitude until 1987. All of a sudden, we noticed the period started to drop like a rock and the amplitude started to come down. And so on the left, this was my homework, basically, is I had to do analyze period over time, and you can see it dropping. And this is just the light curve. You can see the amplitudes going down. Well, there was a paper in 2018 where they were able to conclusively determine that what happened to this star in 1987 was a thermal pulse. And it's been accepted by the community. So we do know at the time when the behavior of this star changed, it was because of a thermal pulse. And it's doing exactly the opposite of what V725 is doing. So this gives you the idea, well, maybe this one's going out while V725 is coming back in. And they're just, different parts of the, they're at different phases of the loop. So this gives a lot of credence, I think, to the idea that this is undergoing a blue loop. But what would be really nice is if we could have some color data to be able to look back at the measurements from the 60s and compare them to today. But before we get there, there's one other paper I'm going to talk about. So Battinelli and St. Serge Demers comes back in 2010 with another of his colleagues. Now they're both at the University of Montreal. And I think that he just wanted to kind of put to bed because he couldn't conclusively prove the nature of the star when he did his study in the 60s. But now modern day has more weaponry to kind of relook at it. And so that's what he does. You'll see Demers in the 60s measured this star in 3 bands, U, B, and V. This is an issue I have with their paper. And this one, when they came back and measured it, they measured it in V, R, I, which are the redder part of the Johnson-Cousins photometric system, and J, H, and K. Those are infrared. That it makes sense because in these cool stars, they emit a lot of infrared. So they actually had to use 2 telescopes. They used a ground-based telescope for VR and I, and they had to use Sophia, that plane that flies up above the atmosphere, to get the infrared observations. So they take these measurements, and they compare a lot of it to Demers. But what they have now that Demers did not have in the 60s is they knew exactly what the reddening is because of the work of Schlegel, where before he had that huge range. Now they knew for a fact that color excess is 0.16, which is actually a 100th less than the range that they thought they were working with. So when Demers was figuring it's probably going to be on the higher to mid part of the range, it was actually much less reddening than he anticipated. Also had the work of Hochschild, which Hochschild, if you look at his paper, it's just like hundreds of graphs like the one I have on here. But this is the most relevant one where you look at different colors and he has them all charted out where all the spectral class stars lie. And you go and you just start trying to fit all your colors in there and find the ones that fit best and see what that corresponds to. So that's what they did. And it kind of landed, so here they look at V minus R and R minus I, and they get this. They also were able to use radial velocities to rule out this being a supergiant. So if you remember, that was one of Serge's or Demers' original assumptions was this is going to be a supergiant. But when they came over here, it got ruled out. That assumption was wrong. The other one that he made was this was a population 2 star because it makes sense. They're mainly population 2 stars in the bulge. However, this one's not. So they were able to determine that it was the best fit or most likely classification for the star is that of a K4 giant of solar metallosity, meaning a population 1 star. So yeah, his 2 main assumptions, which were good assumptions, were actually wrong. And so yeah, that's great. They classified it. But my problem with this paper has always been they classified it at that point in time. The star is clearly evolving. It's changing over time. And because of the bands that they chose to observe it in, we have no way to connect that back to the past because they use different pass bands. The only common filter between, there's no common filter between this work and Schwope. There's one common filter between Demers 73 and this one, and that's Johnson V. So I cannot compare the colors. I can only look at the magnitude and see, look for changes there. I really wish I knew why they didn't at least get B. Sometimes I'm reminded, I'm doing another study. A researcher reached out for me, said, hey, can you get observations of the star? I want V and R. I go put I use remote scopes. I put in a proposal and the guys go, yeah, we can do this, but let's add B and let's add I. Let's do the full photometric system because even though he doesn't need it, that way the data is there in case somebody else does in the future. And I was like, yeah, you're right. Just throw them in there. So I really wish I knew I wish they would have gotten that data, but that does leave an opening for me, and we'll talk about that a little bit more because that's relevant to the project I'm doing. So we're done with literature review. That's kind of the history of this star, and to have a little understanding of what's going on, which brings me to what I'm doing. So as I mentioned, I said, hey, look, I guess I will take this on, and I'll just do it myself, not because it is easy, but because I thought it would be easy. And one great resource for ABSO members is ABSOnet. They have a network of remote scopes and a large committee of people who run it. So they're kind of put into two flavors. They have their what they call their Bright Star Monitor telescopes, and which are all housed by ABSO members, or like in their backyard and stuff. And then faint star monitors are telescopes that are at universities or observatories that are partners. So when I decided to do this, I put in a proposal for telescope time. I said, hey, this is what I want to do, and this is what I need, and we went forward. This was my first time using this network. I've learned a lot since. Probably would have done it a little differently, but for what I was looking to do is okay, so we'll look at a picture here because in a minute, but one of the challenges of observing the star is it's in an extremely crowded field, and it has a companion star 7 arc seconds away from it. The companion star is a 14th magnitude M-class star, so a pretty red star, which means I need a big scope to be able to resolve that companion star out. So my initial ask was I wanted color data, and I wanted to get that without getting the companion. I don't want to measure that in my color data. So I got set up on OC61, which is a 24-inch Cassegrain at Mount St. John Observatory in New Zealand. But they couldn't commit to the amount of cadence I needed to kind of get the data I was looking for. So they also set me up on a BSM scope, Barry, which could not resolve out the companion, but I could get higher cadence on that to do period analysis. So I'm like, okay, great. One of the problems I came up with is like the guys down at Variable Star South, when I told them that I was going to get on this scope in New Zealand, they're like, dude, that scope sucks. They straight told me like he's like, the guys there don't know what they're doing. There's always tracking errors, and sure enough, for several months I was getting data from that scope, and it was awesome. It was awful. Like I would get dumbbells, and it would just a lot of it nonsensical, and I was like, okay, this isn't working. So eventually I had to drop that scope off and go strictly to the Barry scope, and then I had to have filters back in. When I was just on Barry, I was just doing V magnitude and I, because I wasn't using it for color. I needed 2 filters so that I could do color transforms to correct for secondary extinction in the atmosphere. So now I'm collecting data on this scope. This is what really all the Bright Star Monitor telescopes are. They're these 7-inch, these really fast 7-inch Takahashi astrographs. But there is the specs on it. But yeah, I've been getting data on this star with this telescope for 3 years. And here's an idea of what the image looks like. So if you're not familiar with differential photometry, the inner circle is what I'm measuring, and that's where my star is. And then the outer donut, the annulus, that's what I'm using to measure background. As you can see, that's problematic. Like on the blue one, that's my comparison star. I got this big guy right in my background. That sucks. There's nothing to do. These have a lot of. Ideally, you would not have that there, but there's not really much I can do. Right? It's too crowded of a field. For differential photometry, I'm measuring photon counts in mind, comparing the background, measuring it on the comparison star relative to the background. It has a known magnitude. So I can use that to figure out the magnitude of what I'm measuring. And then my other stars are my check stars, which I can use to determine whether my photometry is actually good or not. This is the light curve that I've collected so far, going back to 20. Yeah, the first year I was in 2020, I was measuring, I was messing with the Mount St. John, and I was like, no, I deleted all that stuff out. It was crap. So you can see this is a highly irregular star. So it's kind of like doing its thing up and down here. 2022, it just kind of flattened out for, I don't know, reasons. And then it started to pulsate again on a more kind of normal for it. Pulsation series. But some of the stuff that I've collected so far and kind of analyzed is, I'm looking at things like average magnitude, average color, B minus V, the range, and comparing it to what we've seen in the past. One of the things you can see is from the 3 years that I have data, I was able to collect 168 observations. If you look at both B&D and from Demers, they did 2-year studies, and in those 2 years, they were able to get 25 and 27. Yeah. So that's one of the advantages we have, even using a remote resource like ABSONet. It's not my own stuff, but I can get much higher cadence where I'm getting like 40-ish, or even more than that. Anyway, they're getting like 10 observations a year. I'm getting like 50, 60, observations a year. So there's a big advantage of that. Interestingly enough, if you look at the kind of trend between Demers in the 60s to B&D in 2008, 2009, to me, the average V seems to be increasing, but it's not by a lot. I don't know if it's statistically significant or not. I have to do analysis on that. And plus, I am getting that companion star wrapped in. That's one of the things I need to do, is to mathematically take that out. There are ways to do it. I was playing with it one weekend, but I always get derailed into something else. The other thing is, if you look at average B minus V versus Demers average, I am definitely redder. However, there are caveats. For one, at a glance, looks like it's statistically significant. Haven't tested it yet. But also, if you look at, I went and looked at the range. And interestingly enough, the range seems to be increasing pretty steadily over these 3 time periods. And when I looked at the range that made me look at the range of B minus V. At the top end, we actually measured pretty close, but now I'm getting much redder things. And that makes sense because as stars pulsate, they get hotter at the maximum, and as they expand out, they cool. So that you have a bigger range, you have a bigger range of B minus V2. So I don't know if that's just what's pulling the average down, or if it's something physical going on. That's something that needs to be looked at and analyzed before I can make any conclusions about whether the star is actually getting redder than it was back in the 60s. So yeah, this brings up a good point, because when I first started this, I just started collecting data, but I didn't really have anything in mind about what I was trying to answer. I was just like collecting data. And as over time is changed, I've decided, I was like, you know what, I really should be answering a question. And that question that really begs to be answered, is it redder than when Demers measured it in the 60s? Because that could tell us something, and that's something I could do. And that's, I think, the hole that Battinelli and Demers left by not measuring in the B channel. They could have looked at that, but they didn't. And so that's got me kind of looking at different things. And if I stepped in with that question initially, I would have looked at my project a little differently about how I set things up. Well, I'll talk about that in a minute. Before we get into that, just, you always want to check your photometry. Am I doing a good job? Interesting enough, I have to do some more digging in here when I was looking at it. So again, with your check star, you have catalog data. This catalog data is known to, about 20 millimags. You measure it and go, how good am I? And so I have an expected value. In the V channel on star 4, I'm actually measuring about 60 millimags dimmer than expected, but my precision is super high. I'm at 13 millimags, which is shit high. Anything under 30 is pretty damn good. 10 is like considered exceptional, and I'm at 13, right? On the other check star, I'm not quite as good. I'm at like 20, but still very good. So I need to analyze why I'm a little dimmer there, and I think I have an idea why, which we'll talk about in a minute. My other checks has less precision, but probably more accuracy because I'm right on expected value. But anyway, what that's telling me is I think my data is highly accurate, but excuse me, highly precise. It is definitely highly precise. I don't know if it's highly accurate. One of the reasons for that is that if you remember that picture, I'm using one comp star. If I had things to do over again, I would not do it this way. When I was initially setting up the project, I had a lot of debates with a very old school guy with variable star scale. He kind of talked me out of ensemble. Ensemble photometry used multiple comp stars, and that tends to be more accurate but less precise. Using one comp tends to be more precise but less accurate. I did an analysis. The comp star that I used, they came along because, well, for one, there was no sequence for this star, and AVSO likes people to use the same sequence. They have a dedicated team, so if you're using their photometry tools, they're all preloaded. So if you go to a star and say, the sequence is preloaded in there. If there's not one, you can reach out to the sequence team and they will make one for you. It's a group of very experienced people who look at all the catalog data and say, these are all the best stars to use for comps. I had the guys in Various South sent me their like guidebook of comp stars. It had 9 stars in it for this field. And so I used those. I looked them up in APAS and started just playing with them to see which ones gave me best precision until I settled in on a single, what I felt was the best comp and the best checks based on colors and all kinds of different things. What I should have done other than that is I should have used the same sequence that Demers used, because I'm sitting there thinking now, what I really want to do is compare the color that he came up with the color I'm measuring now. And the best way to do that is to use the same sequence that he used. It's all in his paper. And it's the same sequence that Nelly and Demers used in 2008, 2009. So there have been times where I've felt like you know what? Maybe I should go rerun all of my data with their comps. But that is an undertaking of hundreds of hours. Like, just for I looked the other day, I have 4,999 images of this star. It's like 26 gigabytes of data. So like the thoughts of going back and re-uploading all that and rerunning it, I don't know, but maybe going into next season I should do it. But the other problem I have with that is then I'm losing consistency with what I already have. So I've wondered, like, do I program it in, run it in parallel and still keep the other ones for, break it out and treat it as different data sets. I don't know. Yeah, my other issue is I have an extra star in my data that I have to get rid of. There are ways to do it. I've been messing with it. And I don't think I've been doing it right. The other problem I have, which would be nice when I talked about the amplitude and B minus V changing over the range, is it would be great to phase it with V magnitude. This is very typical what you do when you're doing analysis. But unlike in the past where people were able to get a period, I had not been able to find an actual period in my data enough to phase the data. And in the later papers of Percy, he found the same thing when he was using assassin data to try to see if the period is still increasing. He's getting to now, he's like, it's too garbled. I can't, you can't determine an actual period anymore. It's becoming too irregular. So I don't know if that's something else going on with the star. So there's a lot of things. I've done a lot of work. I've come to almost a standstill of like where to go next. Which I've talked about some of this too. If I can prove that this star is being is redder than it was back in the 60s, that's something that is publishable. And I've talked to editors of scientific journals, said, yeah, they would publish it, but I have to be able to prove it, and I don't have enough to prove it. Yeah, there are some things I need to tweak and look at in order to do so. I don't know if I'll ever get the time. Sometimes I start working on it, for a weekend, and then, I just can't get back to it for months because of, life, kids, job, all the other stuff. Ideally, it would be awesome to find a professor who has like a grad student who could do grunt work for me. But yeah, I think that's where I'm going to go next is start looking at it with Demer's sequence, see if I can de-blend out that companion star to be able to prove with some good error analysis that the star is now redder than it was when Demers observed it back in 68 and 69. And then that could be something that would be publishable. But yeah, I think I've talked a lot. So that's all I'm ending it there. I rambled a lot. I don't even know if I covered everything I meant to cover. I could probably talk about this star for 2 hours.
Yeah. Rich, thank you so much for sharing that with us. I could listen to you talk about it for another
Well,
2
I'm
hours.
glad I'm on Zoom because I can't see how many people I put to sleep.
No, we lost one, but that's only because he has a newscast coming up. So thank you, and looks like you got some stuff in the chat here. Thank you very much for sharing that with us. It sounds like you might, what you spent some time uncovering may very well shed some light on some aspects of stellar evolution that we're theorizing about, but you could be putting a solid dot on that diagram, which is really awesome.
It kind of shows that like there is science to be done, especially by amateurs. Astronomy is really the only science where astronomers can and do participate. There's a lot of collaborations out there because you remember when I looked at the papers of both Demers and Battinelli and Demers, over 2 years, they were able to get like 25 observations of this star because they're using professional scopes. That's why a lot of amateurs, and I get, as I mentioned with Percy, I get people who reach out to amateurs and say, look, I want to do this, but I can't get the time I need to do this. So they reach out to amateurs who are skilled, who have good equipment, and they can do this, if you look at the equipment if you looked at that Barry-scope that I showed you, each of those BFs, Bright Star Monitor stations, they call them, it's $50,000 worth of equipment. That's what it takes to replicate one. Most of it's a mount. It's a Paramount ME, so it's a $30,000 mount. 20 grand for telescope cameras, filters, everything else. So I don't have equipment like that, but so yeah, I've done a couple different studies using that ABSO net. It's really a great resource for ABSO members. Real easy.
Ben just offered that sadly we also don't have the skies for that here.
So Bruce just asked, how hard is it to get time on the ABSO scopes? Is there a waiting period? I know the guys on the committee, they are constantly asking for proposals. They don't have all the time for all their scopes allocated. So whenever they have downtime, which they do a lot, they just go to do survey work. When I mentioned it, one thing that the ABSO does is I mentioned APAS, that's the All Sky Photometric Survey. A lot of people use that survey for comp stars. The professional community uses it a lot. That was all produced by ABSO in those BSM telescopes, but that's mainly done. So when I put in proposals, I usually get answers within 3 to 5 days, and then I start getting data usually within 1 to 2 weeks. If it's transient, which they don't like doing transients, but they will if you say, hey, I got this event and I need it right now, but they prefer, and that's why it's great for long period variable work, because they don't want to dedicate it to if you're watching like an RLRA and you're like, oh, I want to do an entire phase over the course of a night or something, they probably aren't going to be too into that. I know they do, but they like longer period variables where I say, look, I need a observation once every 4 to 5 days. Great. They'll catch it on one of those scopes. So yeah. And if the guys will also help you, like the proposal process is not extensive. There's an online form. You just like say, here's the star, here's the coordinates. I want this, this is the cadence I need. These are the filters. I just want the data, or I'm doing a study. Just something like that. Like a paragraph, and they'll go. They've told me they've never turned down a proposal. So, yeah. Any other questions or any stuff I glazed over as I was blasting? I know I talked fast.
Got 2 questions in the room.
Have you considered using AI?
Did you catch that, Rich?
No.
The question is, have you considered using AI to analyze your data?
I don't know how to do that.
Sure.
I'd have to ask an AI how to have an AI analyze my data.
I mean, it's possible.
I did ask when ChatGPT came out, I was asking it a bunch of questions about this star, and then I found it was lying to me, and it was making stuff up, and it was even making up and I was like, where are you getting this? And it's like, oh, well, it would say some paper, and I was like, look, I'm like, that's not a real paper. It just
Published by Roberts et al. 2025. Hang on.
and then I called it out on a couple of things. It's like, oh yeah, my bad, I'm right, you're right. Like it was trying to bullshit me, and I no, I know a lot about this star. You're bullshitting me. I have a massive Excel spreadsheet with lots of numbers and just many tabs.
Hey, Richard, I saw, caught my eye, your arc second per pixel is pretty high at 2, and you're really close. It seems that you pretty much guaranteed to have some pretty bad cross-contamination there.
I have complete.
3 or 4 pixels is what you want to have your full width half maximum. So I'm curious how you resolve and get past that.
I can't. Yeah, that's one of the issues. That was the problem with the scope that I have access to. And so that is an issue, and that's why I was hoping to get my color data from a different scope, the Mount St. John scope, but it just was not working out for me. The data was constantly just unusable. Because
have you ever looked at a telescope?
What's that?
Have you ever looked at renting time on iTelescope? Not too expensive. I'm not sure how many total per year you cover, but a subscription at $30-something a month at $30 an hour, you can have quality data from Australia at 0.7 arc seconds per pixel, and they have a whole series of really nice telescopes called iTelescope. Small.
Do you know if they have photometric filters?
Yes.
Okay. Interesting.
They go up to 24 inches too, so wouldn't go crazy.
Yeah, that should be close enough. I mean, that's the size that they had in Mount St. John was a 24-inch Cassegrain, and it was able to resolve out that companion. That's the size telescope that Demers used. It was a 24-inch. When Battinelli and Demers looked at it in 08 and 09, they used a 60-inch.
Yeah.
But however, even with that 60-inch, and this is one thing I want to check with, and I might email Demers, as I've wondered if, because when I was doing the math to blend out the companion, I mean, you can do it. I mean, it's doable. I was getting answers that I didn't believe. It was just far too red. And I was wondering if he had it in his data, even with the 24-inch scope, that some of those may have gotten contaminated due to seeing, if the seeing was bad. Because they mentioned it even when they were using a 60-inch scope, that there were nights where they couldn't resolve it and they would have to mathematically deblend. So yeah, I don't know.
Well, thank you.
Yeah, it's a tough cookie to crack because there's also been people who've tried to take spectra of it. Like I would love to see a spectra on it. The first one was in 84 by Wallerstein. And he measured it as a G8 star, which is pretty yellow. And I just don't believe it because of that field. Then when Percy in 06, he had a guy do it and he got it as an M class star. So, I mean, it's a huge spread. And then from the data, if you look at Demer's data and actually apply now that we know what reddening is, it would be an early K star. And then you have Battinelli and Demers in 08, 09 found as a mid K star. If my data is decent, I'm getting it as more of a later K star, which is believable. But the problem is like Spectra would be great and go a long way to figure out what's going on. But that field is so crowded and it's so dim. I mean, you would need an amazingly big telescope and then a shell spectrograph to be able to have a shot at it. And I just don't think anyone's ever been able to pull it off. I don't know what equipment's out there that could actually maybe get it. I know no amateurs have. I know some pretty good spectrometrists. I reached out to one guy that I've used in the past in South Africa, Percy Jackson, who does great work. Has a 20-inch scope, and he couldn't get it. Anything else?
Rich, thank you so much. Appreciate the effort that you put into the research and your time sharing it with us tonight. So if there's no other questions,
My pleasure. I can talk about variable stars all day.
don't tempt me with a good time. No, it's really great.
I had a question, but you ignored me.
All right. What's your question?
It's in the chat.
The waiting period thing, I answered that.
No, the other one.
Do more experienced propose beginner studies as opposed to advanced ones as you have done? Well, that's I answer that because people, when they come in the ABSO, all of them have kind of like different backgrounds and different states. You get some people that are like really like advanced photometry, or they're like master. Usually the best guys are the ones who are like master astrophotographers, and they have all the equipment. They're great, and then you just have to teach them software differences to do photometry. And most of those guys end up doing exoplanet stuff. The ABSO does have a lot of things of saying, hey, these are observable. They don't do, and this is one of the reasons I went to Variable Star South, is they don't really have a model today where they say, okay, here's projects that we recommend and to go out and to do. Is more of observe stuff, put it in database. I do know that the leadership is looking to change that to do more professional amateur type projects and be more project based, kind of like Variable Star South is doing. You could say, you say mine's advanced and not beginner. It's the first one I've ever done. I've done others since. They're probably actually easier, more just collecting data for somebody else. But yeah, but with this being a little bit more advanced, like I said, I made a lot of missteps in how I set things up initially, and it kind of hurts me now. And I wish, if I could go back, I would do things differently. But that's also taught me a lot along the way. I understand things a lot better, mainly from screwing stuff up.
Yeah, a great way to find. With that said, we did run a little over tonight. I don't think anyone's really surprised by that, and I appreciate everyone's patience. And I
had to warn you.
I think, yeah, and Rich did warn me. I think that I hope everyone agrees that it was well worth it. That said, tradition, we have a door prize for tonight. I'd like to ask one of our new attendees to hold the lucky ticket for tonight. What do we got? Last three should be sufficient. 002. 002.
Ooh, he came in late.
Oh, Sean. Sean will be taking home a new copy of Carl Sagan's classic Cosmos. Oh, classic Cosmos. Carl Sagan. Billions and billions of good outfits. All right, depending on the will of the crowd, we have not yet done observing reports, but it's also past time. I will entertain a motion to adjourn or take observing reports.
I motion we could just adjourn.
All right, there's been a motion and second to adjourn. All in favor? All